Right, in looking at these problems, again, do keep in mind that you need to be able to handle these without using a calculator. Okay, so if we evaluate, here we have, in part A, we have repeated multiplication. 3 times 3 times 3 times 3. You can imagine grouping these together if you want to. 3 times 3 is 9, so 9 times 9 gives you a total of 81. Okay, what about B? When we look at B here, here the base was very clear. The base was a 3. What's the base in this second example? The base of that power 4, is it a 3 or a negative 3? It's just a 3. Okay, so the base is the number that's going to be repeatedly multiplied. If there's no grouping symbols around it, the negative simply indicates change of sign. Okay, and remember, order of operations says you do grouping symbols first, then exponents, then multiply and divide, and then add and subtract. So the exponents come before this multiplying by the change of sign, by the negative 1. Okay, so when you multiply this, you have your negative, and then it's 4 3s. So that negative is still going to stay out front. So you get a negative 81 for your answer to B. All right, if we look at C, now what's our base of the power 4? Now the base is that whole thing, negative 3. So now, as you look at this, you're going to have negative 3s multiplied by themselves 4 times. So now every 2 negatives cancel, and so you get your overall product is positive. So here you wind up with a positive 81. Okay, be careful and distinguish between forms like B and C, and to avoid common mistakes. Okay, and then finally the 1/3 to the power of negative 4. So if we apply this negative, the property of the negative power, we're going to take this fraction 1/3 and flip it. So what's the inverse of 1/3? Just 3, change the sign to 4, and we saw over here, 3 to the 4th is 81. All right, let's look at this second row. Okay, in the second row, looking at E, our base with the power 0 is the whole expression 5t. So what do we know its overall value is? Just 1. Anything that's non-zero, any base that's non-zero to the power of 0 will always have a value of 1. Okay, if we look at part F, here we have this power of negative 1. The base that power applies to is the whole product, 5t. So that entire product gets moved to the denominator. And we take it to the power of, we change the sign to 1. We don't need to write a power of 1, so we can just leave it in that form. Right, in G, the power of our exponent with a base t, or with a power of 0, is what? 5t or just the t? It's just the t. So really we have 5 times t to the 0, which has a value of 1. And so our overall answer is just going to be 5. Okay, and then our final example here, 5t to the power of 1. Again, a power of 1 does not need to be written. So we just leave it the variable itself. And so 5t would be our answer for H.